Okay, and the last thing on special products is this idea of sum and difference of two cubes. So the idea here is like instead of squares, we have cubes. Well, what is a cube? What is a perfect cube? Let's talk about cubes for a second. So a cube is literally a, yes, so it's like a square, but it's instead of two-dimensional, it's three-dimensional. Now, when we find the volume of a cube, let's say a cube has all sides the same. So if the width is 2, the length is 2, the height is 2, the volume is going to be 2 to the third power. That's why you hear about volume. Volume is cubic, right? It's how many cubes fit into something. The volume here would be 8. So if I had 1 to the third power, what would that be? What's 2 to the third power? 8. 3 to the third power? 27. 4 to the third power? 64. Close. You're very close. This is just 4 times 4 times 4, right? 4 to the third power is 64 because I'm just multiplying 16 by another 4. 5 to the third power would be 5 times 5 times 5, which is 125. Okay, let's do 10 to the third power. We know that from scientific notation. 1,000. 100 times 10. 10 hundreds gives you 1,000. So these are what we call, just like we had perfect squares, these are what we call perfect cubes. Okay, so you don't see these do not come up that often, but you have these special cases, the sum and difference of cubes. Essentially, if I were to multiply, and remember that would be FOIL, 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 if I were to multiply this out, I would get x cubed minus y cubed. If you don't believe me, go ahead and multiply it out, okay? Same thing here. If I were to multiply this out, meaning x times all of these, y times all of these, I would get x cubed plus y cubed. So these are, we usually give you the formulas, and since I let you use notes on your test, you can always, write them down. Essentially what I want to figure out is what to the third power would this be? Well, we just said 64 is a perfect cube. What number to the third power is 64? 4. 4x, right? This is 125 is what number to the third power? 5. So you see, that means that this is x and this is y. Which one of these formulas should I use to factor this? I'm going to use the sum of two cubes because of the positive sign here, right? So if I factor this, I get x plus y. X is 4x. Y is 5. You see that? Times x squared. What's 4x squared? Yes. What is, we're going to go minus x times y. What's x times y? So in essence, x is equal to 4x and y is equal to 5. What is 4x times 5? 20x. And then you see on the end it's plus y squared. Y is 5. What's 5 squared? 25. Okay. Now this one, I want to first identify what number to the third power minus something else to the third power. So 27y cubed. 27 is what number to the third power? 3y. 3y to the third power is the same thing as 27 cubed, correct? What number to the third power is 8? 2. So that means that in this formula right here, okay, x, wherever you see x, x is equal to 3y. And y is equal to 2. A lot of times I use a and b. That way it doesn't get so confusing with so many x's and y's. Okay, so 3y minus 2, you see how that is in the first position. X squared would be 9y squared. I just squared this term, right? There's the x squared plus x times y. 3y times 2 is good. Plus y squared is going to be 2 squared is 4. That's it. Okay. So I'm going to stop the video on sum and difference of two cubes, and I'm going to give you a few more practice problems on this one.